This is exercise 64 in chapter 6 of our textbook, where it says a machine fills containers with a mean weight per container of 16 ounces. If no more than 5% of the containers are to weigh less than 15.8 ounces, what must the standard deviation of the weights equal? So again, let's draw a picture of this situation. We've got a normally distributed situation. We know the mean is 16 ounces. We don't know the standard deviation, but we know some amount down here below the mean, where x is 15.8 ounces, has an area below it equal to no more than 5%, or 0.05. So the first thing we're going to need to do is find that z-score. First thing we always need to do in a normal situation is find the z-score. So we have to look in the body of our table and try to get as close to 0.0500 as we possibly can. And we've got two options here. We've got negative 1.64 for a z-score and negative 1.65 for a z-score. They're both equally distant from 0.05. One is 0.0495 and the other is 0.0505. So I could use either one of them or I could average them. So I'm going to average them this time. So I have a z of negative 1.645. So now that I know z, I can use my z formula to find the missing piece in that formula. Z I know is negative 1.645. X I know is 15.8 ounces. Mu I know is 16 ounces. What I don't know is sigma. So just like I did in exercise 63, I've got to multiply both sides by sigma first, and I'll get negative 1.645 times sigma is equal to 15.8 minus 16, which is negative 0.2. Sigma is being multiplied by negative 1.645, so I undo that by dividing both sides by negative 1.645. And when I do that, I get a standard deviation equal to about 0.122 ounce.